It is my pleasure to introduce our speakers today. We have Elastio's Chief Scientist, Srini Wardarajan, and our Product Director, Ishwar Nalamaru. They are going to talk to you about how you can protect your S3 buckets from cyber attacks with advanced ransomware and malware scanning. And with that, I will hand it over to you too. Thank you.
Thanks a lot, Laurel. Hi, so those of you who don't know who we are, so we are Elastio, and we've built a competency essentially with our core strength being in ransomware and malware detection across a slew of AWS platforms. So we currently detect ransomware and malware in EC2, in EBS, in ECS, EKS, EFS, FSX, as well as directly within AWS backup recovery points. We're a partner of AWS backup in the process. So what is it exactly that we do, and where does our strength come from? So our goal is to ensure that the data that is within your systems, whether they be production systems on one side or backup systems, is to ensure that that data is clean. It doesn't have ransomware sitting within it. And in order to achieve that competency, we spent the last 3+ years in looking at every single family of ransomware written since 2014, over 2,200 families. Each one of them we had to disassemble, disconnect from their command and control servers, basically neutering them, and then detonate them to see exactly what they do, what kind of artifacts do they leave, what kind of encryption algorithms are within use, what is their behavior and how they detonate. Is it one big explosion, or is it like lots of trickles of encryption activity going on? So there are lots of nuances within that. And the net of that work essentially told us for each of these families exactly what is going on, allowing us to build a deterministic, comprehensive picture of everything known out there. About last 6 months or so, we've been deep inside the unknown territory, in the sense that we get about 25 to 30 samples a week that have not been yet seen in the wild. So we're running a few months ahead. And the whole idea is we want to keep ahead of the curve. The second part of our work was in building a statistical model that effectively it takes all the information that we gathered from the deterministic analysis and builds a model such that it can capture not just the behavior of the known families, but any combination you can produce out of those behaviors. So how good is that model? Out of the 25 or 30 unknown ones we see every week, on most weeks we catch the entire 100%. In other weeks, we might miss one or two, in which case the model updates. And so that is where our strength is, having a deep understanding of exactly how ransomware behaves and what the process is that goes on around it. So given all of these capabilities we built in scanning much of AWS's infrastructure, the big new announcement that we have is we now scan S3 buckets as well, essentially completing the file object block hierarchy within AWS. And so why is this important? And today's talk will focus essentially on what are things that are unique. It's in the basic things that Elastio does. So we are the only solution that goes after both categories of attack vectors, which is live data in production systems. So they could be snapshots, they could be S3 objects being accessed, and at the same time being able to detect ransomware and malware inside backups. And in today's example, I'll actually show some attack vectors that cross these boundaries, where you may not be able to detect it in one domain, but in another domain, you will detect it later. The second strength that we have is, particularly when we're dealing with live snapshots and ingesting data, we can get you to uncompromised clean recoveries in minutes. This is not a long backup restore process. And we have some interesting techniques that we use with snapshots and clones within Amazon in order to get that recovery be done lazily, so it doesn't depend on how big the volume is. And you can quickly get back to operation in there. The third thing that we found and we built our strength in is being multi-cloud. We deal with AWS, we work with Azure and Azure Backup, and we work with several backup platforms and VMware environments as well. The whole idea being we're as a platform, we protect a variety of different infrastructures because many of our customers are in one way or the other hybrid and multi-cloud. Where our strength lies, and we are not a replacement for your existing EDR, XDR solutions, whether you're running CrowdStrike or whether you're running Windows Defender or Sentinel-1. You should continue to run your XDR solutions. But there are scenarios in which they get bypassed. There are well-known loaders, techniques from within Blister, as an example, that's used by Lockbit. where there's a form of self-reflection they do within the binary, figure out the library on which the EDR agent is hooked onto, and then very specifically bypass the functions that they're calling by reflectively loading another copy of a clean DLL. For example, NTDLL is a very common entry point in here. So by bypassing the EDR solution, you're suddenly now running blind. Whatever is happening on that endpoint system, you have no awareness as to what is really going on. And this is where we come in very handy, because we operate agentlessly. We operate outside the system in snapshot, so we can't be unhooked. So we provide protection in exactly those cases where EDR agents get bypassed. And finally, as a solution, we are agentless. So as a solution, we are agentless. So you're not deploying anything onto your production infrastructure. And we operate within your account entirely. Our detection algorithms run inside your account, so your data doesn't leave your network and your data doesn't leave your account at all. All we have is a SaaS portal on the other side that shows you the findings that came from the scan, but no data exits the premises. So what are some of the attack vectors when you're dealing with S3 that we come to protect against? So there are sort of two ways of looking at this problem. One in which S3 is acting as an entry point. So that is where the attack itself is originating from in one sense. And in another, it is acting as a distribution point. And so these are sort of two classes of attacks. So let me take an example. So S3 as an entry point for attacks, the common threat vector over there is either a misconfiguration of buckets, which people are looking out for, or some form of IAM credential loss, which allows an attacker to get access into a bucket. That is one way of doing things. The second way of getting access to a bucket is actually a little worse. So these use wormable techniques. So the basic idea is this: the bucket's name itself is globally unique. There are lists of known buckets out there, and there are fuzzers that will create unique names and attempt to guess the name of a bucket. So effectively, you're doing a spread attack. You're going after a lot of unique buckets to see if any of them are open. Now, the interesting thing you do with it after that is you don't actually go and put anything into the bucket. You search inside the bucket to see if there are further credential files lying there. Either keys are lying there. If you're really lucky, you might get the entire .ssh directory of someone. But even if not, in many cases, you end up actually with credentials to other secure buckets. Now you have a correctly configured bucket that requires authenticated access, but because the credentials leaked from elsewhere, someone has gotten into a bucket they shouldn't have gotten into. Now, what do you do after you get into such a bucket? Right? How does an attack actually begin? So there are one of two ways you can do this. One is simply replace an existing user file. Many of these buckets are actually used for storing file data. So a very simple attack vector over there that you can do is replace a Word file in there with one containing the iced-id loader, or at least the initiation sequence for the iced-id loader. Many loaders can be dropped over an existing Word file. So the Word file opens up, you turn on enable editing, and boom, the next stage comes in as a PNG file typically. And inside the PNG file is hidden a DLL that then launches into memory. So this is fundamentally the problem. You can directly get an attack vector because a file in there has been replaced. So getting into a bucket is a fairly dangerous operation. Once it gets in and the loader fires off on some machine, then after that, there is a standard process of lateral spread over there. And then it will start running through much of your infrastructure. Funny thing over here is, as it's doing the lateral spread, you will start seeing signs of something that originated in S3 now start to show up on EBS and other storage systems as other systems pick up this spread. The second kind of attack is interesting. This is where S3 is being used as a distribution point itself. And there is a whole class of attacks over here that arises because of technically what are abandoned buckets. So a relatively recent attack in here came against those of you that are familiar with this, NPM, Node Package Manager. So typically, open source packages have dependencies. So some packages will load other packages that they need as essential dependencies to their operation. So one recent one that got attacked was Bignum. Bignum had a dependency on another Node package, except that other Node package was hosted in a well-known AWS bucket that was abandoned by the developer. At which point, what happened is a hacker took over that exact same name, and under the same Node package name is now distributing directly into existing software systems, is now distributing malware binary. And so this is dangerous because this comes into software bill of materials and being able to scan through all of your dependencies, which for large open source repositories is quite complex. And now what happens is there, S3 started as the origin engine that distributed this. But where are you possibly going to find it? In an EBS snapshot elsewhere. Scanning the S3 is very important, but by the time you see the thing in the EBS snapshot, it has already activated and is starting to move across. So these represent the sort of two major classes. There is a third class of attacks that involves ransomware and encryption of your S3 buckets. We have not seen this one in the wild. I will only give one part of the technique, which is it involves using a encryption with a key, but the key is not from that particular account. It is a shared key from an attacker's account. So your data is encrypted with an external key. And when the key is dropped, all your data is essentially locked. Till access to the key is allowed by the attacker, very slowly you don't realize your S3 buckets are getting encrypted. This so far has not been attempted much in the wild, but it's a line of attack that is widely expected to happen fairly soon. With that, I will pass it to Ishwar to walk you through exactly how the S3 backup scanning works.
Cool. Thanks, Srini. So as Srini has pointed out, like S3 could be either an entry point or a distribution point for spreading the malware or ransomware which you have. And the disruption could be in two ways. For example, you can have a business disruption. And also there could also be legal scenarios where you're liable for the end user because your S3 bucket, they're downloading something and then they're getting infected. And when it comes to use cases, you can have like, we think there are like 5 use cases here, especially when you're migrating the data from the cloud. So you really want to start clean with your environment, and therefore you want to scan before you're setting up your environment. That is one. And second is the compliance requirements. So compliance requirements could either be internal compliance. For example, we want to scan this bucket every 3 months or 1 year so that we can ensure that everything is clean. Or it could also be, in some industries, it could also be from a regulatory point of view that you need to ensure that all your data is recoverable. When you say recoverable for S3, you don't want to back up everything because the backups are costly or whatever it might be. So you might enable worsening of it. And even then, you want to know whether those objects are clean or not. So that could be one use case. And then the other thing is, so like Srini mentioned, a PNG file could actually carry a threat vector. So when you have like different kinds of files which you get uploaded from your customers or internally from your employees, etc. So you just want to ensure that the content itself is clean so that your environment is protected. And then the fourth use case is data pipelines. Like as you can imagine, all your big data analysis or any of your data lakes, whatever it is, you have some ETL processes which are in place, and the sources of them are like from multiple places, and you want to ensure that the data which you're putting into your data analysis is clean and everything is free of it. Again, if you're working with like a lot of third-party vendors or integrations where you're collecting data, you want to ensure that your environment is not getting protected and your applications are always safe. So that could also be a use case where you really want this S3 scanning itself. And now moving on to these are like real life case studies which we have done with our customers. So in this particular case, the customer really they have a lot of so they protect the data of the legal firms, and because the data is like really sensitive, they really cannot go and then open the data or do anything. But what we can provide, so what they wanted to ensure is like the legal firms itself are not getting infected, because that's a big threat in the legal sector, because in many of the cases there are some credential leakages which would happen in the legal field, because those files, the legal applications or the legal docs which they have might have some sensitive data. So what they really wanted was a solution like, how do you ensure that all these data which are uploaded or like being migrated to the cloud or like really clean. In this case, what we did is essentially, before a customer data is set up or like say data is moving into the cloud and into the application data, we'll essentially scan everything in an S3 bucket, and they can ensure that all these data is clean. And and then going forward, they also have enabled like EC2 and ABS workload scanning, which we already do. So we're providing like end-to-end results for these customers. And what did they get out of it? It's like it's very audit-ready documents or any requirements which they have. You can always ensure that your security is being protected. You're scanning your snapshots every day, and your S3 with your object log, it is also being protected. So your entire environment is getting protected there. And the good part is because we protect other services, they can use a single pane of glass in terms of like a single UI where you can actually see all the threat vectors across your AWS platforms in one screen. That's one. And then the second case study is essentially this is from a firm which collects the data from like multiple people across in the field, especially in terms of like the contract workers and all those stuff. And they really didn't know what the customers were uploading. So they upload multiple kinds of files. They might upload harmful files, so we don't know. So what they did is they implemented a schedule scans for S3. So every 24 hours, we go and then pick new objects and then scan for it. And the way we do it is also in a cost optimized fashion. When you compare us to other competitors, we use on-demand instances. So your instance is not running the entire day. It just runs for the amount of the time which you're scanning, and then it's immediately killed. So it's optimized for your costs. So as you can see, they can now offer like they can like the customer can now offer the end user in terms of like the protectivity against malware for the files which they do. They can fulfill their compliance requirements, and therefore they can also increase the customer trust in a cost efficient manner. So these are like real life two case studies here. And now moving on to the part of like, okay, how do we scan the S3 buckets? So you guys might have any questions. If you have any questions, you can put it in the Q&A and we can answer as we go. So Elastio, we deploy with a CFN template, and then we operate agentlessly inside your VPC. So the data is never moved out of your VPC, only the metadata of the scans, maybe the path of an infected object. That's the only data which is moving out of your environment. And each scan runs as an AWS batch job on an ephemeral on-demand EC2 instances. So it's not a static instance running continuously to save your costs. And when a scan is triggered, what we essentially do is we call S3 APIs to list all the objects. And then we see what objects are not scanned, and we go and scan for them. You have options either to scan the existing bucket of the entire objects, the list of the objects, or any object which is being created from now on. You can also scan those things. And how do we perform the scans? So we essentially mount the S3, and then we perform the scans on top of it. And we give multiple options while you create a plan for scanning. I'll also demo all these stuff for you guys. So like you can either specify a specific prefix or a path or glob. You can filter all your objects based on these things. Or you can also specify just scan for new objects or just for scan existing objects. Or you also have an option for scanning between a time period. For example, I want to scan all the objects which were created or modified from like 2 months back to 3 months back. You can specify, and then we can go and scan for those things. And scans are smart enough that you don't have to download the entire object itself. So we are smart enough to catch or like just download the bits which are required for scanning, and then we can scan for it. So this also, again, it optimizes your cost. We don't have to use a lot of get calls for this one. And just to give a quick architecture of like how Elastio's S3 scanning works, this also very similar to all other scannings which we do across our EC2, EBS, and all that other stuff. What we do is essentially all this red box which you can see is sitting inside your account. So what we are essentially doing is inside your account, we are deploying a CFN stack. And Elastio assumes a read-only role where we go and then list all your S3 objects. We mount it, and we mount it to an ephemeral instance. There, what we do is we essentially scan for any ransomware and malware. And we also provide the options to either schedule the scans, or you can also perform on-demand scans here. So that is one. And coming back to like what differentiates Elastio from others. So we're the only one in the market who can actually who can actually catch ransomware encryption in your data. There's no other player who can do that on AWS. And we also directly integrate with AWS Backup. You point out to your EBS snapshot or your EC2 backup from AWS, we can directly pull it in, scan you, and then throw the results for you in your security hub or any other your SIEM tools or ticketing tools which you have. And again, when it comes to specifically S3, we have a lot of options here. You can scan existing object, you can filter out the bucket and then scan partial bucket. I don't want to scan everything, but this is an important path for me or prefix for me. Just scan those things. You can either schedule the scans, and then one more option which we are currently working here is essentially scan on object creation. This is essentially you can say it's a near real-time scanning. As soon as you upload the object, you can see the result. That is something which is coming soon. And unlike other vendors, we don't have any object size limitation. For example, the maximum object size possible in S3 is like 5 TB. We can hit all those buckets, or like we can hit all those objects and then scan for it. There's no size limitation which we have here. Okay, so this is the Elastio's console here. We call it Elastio tenant. And here you can have like multiple views. For example, if you want security view, you can see how many ransomware, malware, or file. We also determine file system corruptions, which you have, which in your like file systems, EC2 or any other file systems, you can actually get it here. So I'll just, because of the context of this call, I'll just go and create a policy for S3. So like, let's say the creation of a policy is pretty much easy here. Let's say webinar S3. I can go here. And then like, let's say I'm scanning for there's no file system integrity for S3. You can choose all those options. And you can pick your S3 bucket. Like, let's say I'm just picking this up. You can select the paths. You can either do a path prefix or a glob. You can enter, for now, for the sake of time, I'll just go for all paths. And then save and run. Okay, that's it. So we have the policy created here. It would run accordingly. Like it would take a few minutes to start the scans. But before that, I already scanned once. So let me go through. So you can see it's color coded. So this seems all of the buckets are clean except for this one, which has a red dot. So I can click on it, and then I can go for scans, and you can see a bunch of scans which are happening. So in this particular case, we are almost running like every hour or something, but you can see it. And here you can see how many files are scanned. You can download the reports, and you can also see the paths along with like which threat is identified and when was it first detected. This is really useful when you're really searching for, okay, which time frame should I actually see when an incident happens. And you can see all these things here. So that's a quick demo for S3 here. I'm okay. We see a question, Srini. Can you scan on-prem and Azure for multi-environment customers? Okay, so we as we are speaking, we are building a solution for Azure in terms of like we want to integrate with Azure backups to start with. And our target is by like April of 2023, we're entering Azure. And
24, sorry.
Oh,
3 months from now.
Sorry, 2024. My bad. And then for on-prem, can I know, like, for example, we're directly integrating with like the Veeams,
Backup
Rubrik,
systems.
OSCT, all the backup systems. So if you use any of those things, we directly integrate with those things, and we can scan for those environments. If you have any specific question on what kind of backup you use or what kind of environment, VMware, Hyper-V, we're open to answering any other questions.
Yes, basically our whole target is to be truly multi-platform. Many of our customers are multi-platform, and thus the push here as well.
And we're closely working with like Azure customers and on-prem customers. We're actually building in their environments types of.
Yes, so I can take this.
Yeah.
So the backup systems that we currently deal with on-prem that are either deep in development or finished include Veeam, Commvault, Rubrik, Cohesity, NetBackup, and Zerto. Other systems will keep getting added as we move along, essentially.
And with that, Ishwar, Srini, thank you so much. This was fantastic. And to all of you, thanks for coming. And we will look forward to seeing you at the next one.